Alright, so let's look at the type 2 of criteria D questions, which are design questions. And the first on this list is November 2016, question number 7, Windmill Layout Design, Equations Plug and Play. So in this question you will obtain relevant information and use reasoning and methods in order to design a suitable wind farm. Okay, the video provides some background and we have some formulas. Let's go on. Circumference of a circle, area of a circle. Okay, determine the exact area of a circle. Area of a circle is pi r square. Leave your answer in terms of pi, meaning you don't have to use pi as 3.14, just leave it as pi. So pi r square, pi 65 square, that's your answer. And I can show that from the marking key as well. Just pi and 65 square. Use the 65 square and your answer is going to be 4225 pi. So please write the proper notation for pi. Don't write pi as pi. Right. The wind turbine, its efficient power PE in watts is calculated as about 45% of the available power. So I am being told totally new information that my teacher never taught me. The available power, the efficient power, again the formulas are given. I'm gonna plug and play. U is the wind speed in meter per second. A is the area of the circle, already found previously. Calculate to the nearest kilowatt the maximum efficient power. If I want to find the efficient power, it's going to be 45% of PA. So first find this guy, then find the 45% of this answer, which is going to be given to you by this. You have all the speeds, you have literally everything. You want to find maximum, use maximum speed, maximum everything. Okay, so plug and play. Use the maximum speed, plug it over here, use the area, plug that over here in this, and basically you are going to get your answer over here, and then find 45% of it, which is easy. 0.45 should be multiplied with PA, this answer over here, and you'll get your answer. Okay. Alright, so wind turbines need to be placed quite far apart so that the air turbulence from one wind does not affect the other. Yeah, that's true. The wind turbines are spaced out at a distance based on the diameter of the rotors. Okay, so from any wind turbines, the distance is generally 5 times the diameter of the rotor. So this is the diameter over here, which you found of the rotor, that is 130, like it's given to us. So 5 times that diameter, we're gonna have that. So you're providing with a rectangular area to plan the wind farm, and the rotor diameter is 130. The rectangle has these widths. Okay, we will be able to see that. Show that the radius of the circular zone, the turning zone needed for the wind turbine, is 325. Okay, so obviously to find the radius of the circular zone or the turning zone needed for one wind turbine is 325. So come back to this diagram over here. For two windmills, this is a gap of 5 circles. So let's imagine one windmill needs half of this distance. Okay, so one windmill needs 2.5 circles and the other one needs the gap of 2.5 circles as well. So 130 130 plus half of 130, which is 65. 130 plus 130 plus 65, it gives us the exact answer of a 325, and that is our answer for this question. Easy. So we come to this question: design a wind farm using 130 as a diameter. This has the dimensions given over here. Okay, so in your answer you did identify the strategy for the most efficient wind turbine arrangement. The maximum number of wind turbines that can fit inside the rectangular area. Estimate the maximum efficient power. So if we can find out the number of wind turbines, we can find out the power. That's also really easy. Consider sustainability features and the degree of accuracy for your estimate. Okay, so we know that the tuning zones, or basically the wind turbines, are going to be over here. So the gaps between every wind turbine need to be left in a way that they don't violate any of the conditions previously mentioned over here, and also making sure that between every two wind turbines I leave a gap of 650. Okay, so when I place a circle over here, one windmill is going to be assumed to be over here on one side of the circle, and one windmill is going to be assumed to be on the other side of the circle over here, because that's a turning zone. Okay, so I can place the circles, and this is actually a drag and drop question. I'll keep on dragging and dropping until I cover this, and I can even do it mathematically. Like if I just divide 4000 by 650, I can have an idea about how many gaps like these can I have over here. And if I divide an 1800 over here with this also, I can then have an idea of how many rows can I basically make over here. So it's basically me doing the math and actually then putting it into practical shape by dragging and dropping, and with that I can then find the estimate of the maximum power. And then sustainability features, obviously for the sustainability we need to make sure that we insert the math, as well as from the marking key we need to make sure that we also cater for the wind speed. Okay, so the area experiences an average wind speed and of 30 meter per second, and since the turbine do not operate beyond this wind speed of 30, this means that the turbine will not be operating for half of the time at least. Okay, and then you have more sustainability features. Now obviously these can be learned from the video, because most of this information was from the video. And then justifying the degree of accuracy, how can you guarantee that the wind speed is going to stay constant? We have some windy days, we don't have windy days. It's the same like solar, we have sunny days, we don't have sunny days. So literally you can see that, and if you have used any rounded answers in your calculation, you can mention that also. So in most of the cases it's inaccurate. All right, and this finishes the first question. Moving on to May 2019 car park design. So this is the car park design question. We have a video. It's really important that we watch this video and we figure out the two scenarios of car parking: the angular car parking and the second option, which is going to be given to us as perpendicular parking scenario. Okay, so our first question over here is going to be, let's see from the images, determine the value of the minimum lane width AB needed for the cars to enter and leave the perpendicular parking spaces. So we need to find this, which is somewhat like the radius of this quarter circle. So in order to find this, we basically need W plus R, which is going to be this. So R plus W, we know what R is, we know what W is, simply add them, and there you have your answer over here, which is simply put over here, and we have the color coding as well. Number 2, angular car parking. So for the angular car parking, we need to read all of the sentences. FG is perpendicular to DE. When two lines are perpendicular, they make a 90-degree, meaning I have the possibility of having a right angle triangle in which I can apply Pythagoras and trigonometry. Given that DE is equal to AB from part A, that's really important. We can copy paste that information. DE is equal to AB from part A. All right. So our first question, find the turning arc length. Its formula should be remembered. It will not be given to you in the exam. Angle over 360 into 2 pi radius. I'm not saying 2 pi r because small r is taken as turning radius. This is not what I am looking for. So be careful about the symbols. So angle over 360 into 2 pi r, that is basically your answer. The angle is basically the angle made by the sector. All right, moving on, find the value of DG. It's a 4-mark question. DG, it belongs to this right angle triangle, so I'm going to use the right angle triangle over here to get it. Okay, so if I can know what DF is the same as DE, which is the same as AB from the previous part. Okay, so I know that complete length. Okay, and so I know DF, I know the angle. Why don't I just use sine cos tan to find out DG? I still don't understand why is this a 4-mark question, but it is. I'm just gonna basically draw the triangle separately, label the sides, and use cos to find out the angle. That is 1.4, correct to 1 decimal place. That's what 1 mark was for. Okay, rounding is really important. Non-rounded answer, then the rounded answer. Determine the value of minimum lane width EG. Okay, so if you want to find this, just from the total DE subtract DG so that you can get EG, which is X. Okay, simple subtraction. All right. You are a designer of the planning department, and these are your conditions. Design a car park to maximize the number of parking spaces. Use either perpendicular or angled parking, but not both. Use 5.5 as minimum lane width for perpendicular parking, 4.0 as minimum lane width for angled parking. Okay, make sure to follow the conditions. Now, obviously, design a layout. In your answer, you should identify the relevant factors. Well, my factors, as easy as pie, they are going to be the conditions that you impose on me. They are also going to be the size of every car. So the size of every car also depend on how many cars can I fit in there. The size of the parking lot, the dimensions of the parking lot, that is also going to be a factor. The type of parking that I choose, angled or perpendicular, the distance between every two cars, which is the distance needed to open and close the doors. Again, all of the distances, all of the sizes, all dimensions, all factors, all conditions, they can be written over here. So write down everything, even these conditions. Okay. Justify with calculations that your design is making the best use. And how do you make the best use of the space? By having the maximum number of cars there while following the conditions. Okay, so you need to do the calculations for it. Okay, so make sure if I use this canvas for the perpendicular parking, I'm gonna place a perpendicular parking scenario over here. Okay, then I'm gonna leave the gap. How much gap should I leave? I need to use 5.5 meters. Okay, so placing one over here, leaving 5.5, then placing another, leaving 5.5, then placing another. Okay, so I think I can assume to have 15 cars over here. All right, so make sure that you follow the conditions. Okay, 5 meters, this is 5 meters, so 5.5, this gap should be left between lanes. All right, make sure that you understand that, and I'm going to show you an example. This is a gap of 5.5, like almost 5.5. Okay, make sure you follow that. Okay, do not violate any condition. It's as simple as that. You have a total of like 28 meters, and you have one complete width as 4.5. So 4.5, then a gap of 5.5, you complete a 10. 4.5, then a gap of 5.5, you complete another 10, then 4.5. That's it. And you can write that in words to basically show your calculation. There's no fancy formula for the calculation. It's generally some division or addition or subtraction. That's it. No fancy formula. Keep it simple. All right. And if you want to use the angle parking, I can show that to you later. Justify the degree of accuracy. Let's see the angle parking also. So these are basically the calculations. Again, mention, copy paste, answer. The total width use 10. 4.5, 5.5, total width 20. Third card lane 24.5. You just have 3.5 left. No more gaps, no more lanes. You leave. Easy. Keep it simple. Justify the accuracy. All like we mentioned some of the factors which are bound to change. Do you control the size of cars that gonna enter your parking lot? Can you control whether a Fortuner enters or a Suzuki Cultus enters? Come on, you can't do that, and both of them are of different sizes. Okay, so it also depends on that how many cars can actually get there. Most of the distances are actually bound to change. Okay, all cars do not have fixed dimensions. Every car has different dimensions. Okay, all right. The canvas for angular parking, again you can place angle parking over here, but make sure to follow the minimum lane width distance. Okay, over here he has followed the 4.5 or whatever it was given at the start of the question. But for angle car parking, he also allowed you to do some rotations, so you could have placed your cars like this, so that both the car lanes can use these as paths to move. This was the only tricky part over here. So I think in the exam, when you are basically confused about which parking to choose the simpler one. Don't choose the complicated option. Choose the simple one. Okay, and over here you can have 16 cars, slightly more than you like, one more than you could have in the perpendicular car parking, but there's no deduction of marks. You will get full marks. Okay, and that is it. This is where you finish your question, because you've illustrated only one design. Only illustrate one design. This This is where you finish this question. So on to May 2022, the cinema seating design. It's all about following the rules. Let's go. May 2022. So these are all of the conditions, all of the videos about cinema seating. And this is a very intimidating diagrams. I see more than 20 different dimensions over here and I am confused. Let's read the question. Okay. So calculate the maximum number of tiers for a height of 6 meters. The height of your cinema is 6 meters. How many number of tiers can you have? Tier 1, tier 2, tier 3, tier 1, tier 2, and tier 1. This question is related to height. So see how the height is changing. Everything else is bullshit. Okay. So for 1 tier, this is your height. For 2 tiers, this is your height. For 3 tiers, this is your height. It's like an arithmetic sequence where 1.5, 1.9, and 2.3, it's increasing by 0.4 meters every time you add a tier. So why don't you label this as an arithmetic sequence and get to work? You can do that. You can make up a formula of arithmetic sequence. You know the total height or the total term that you want to reach to is 6. You just want to find out n, the number of terms or the number of seatings. Okay, when you do that and you do the math, you'll end up with 12 tiers. Okay, you needed 12.25 tiers. There's no such thing as 0.25 tiers. It's 12 tiers. You can't go to 13 tiers. Method number 2 is, why don't you just keep on adding? Start with 1.5 as your first tier, add a 0.4, you get 2 tiers, add a 0.4, 3 tiers, add a 0.4, 4 tiers. You know that copy paste works in your e-assessment, so keep on copy pasting until you reach 6 meters. It's so easy. You'll get full marks. Moving forward, each section should be 3.5 meters wide. There should be a gap of 1.5 between each two sections, and there should be a gap of 2 meters on each side of the complete seating section for exit and entry doors. The total width is 30. Can you show that the number of seating sections are going to be 5? Again, do this with the process of addition and subtraction. No need to come up with a creepy formula. I have done that, but why don't you keep it simple? Let's first leave 2 meters and 2 meters for the entry and exit doors. So out of 30, we now have 26 meters to play with. So 26 meters to play with. First seating section, 3.5 meters used. Gap of 1.5 meters used. A total distance of 5 meters has been used in a 3.5 meter seating section and 1.5 meter gap. Another seating section, 8.5 meters used. Another gap of 1.5, 10 meters used. Another seating section, another gap. Another seating section, another gap. Keep on doing this until you reach the limit of 26 meters, which I have used, because if I place a gap and place another seating section, it's going to cross 26. I can't do that. Show that 5 seating sections were possible. Shown that through calculation. Just show the addition as easy as it gets. Okay, full marks. Let's do this. 7C. X represents number of seating sections, Y represents number of tiers. We know that the maximum possible seating sections are 5, the number of tiers are 12. They can be lesser than 12, they can't be more. This can be lesser than 5, this can't be more. Okay, so vertical line less than or equal to 5, X is less than or equal to 5, that's a vertical line. Y is less than or equal to 12, that's again a horizontal line. Every horizontal line is Y equals to a number, every vertical line is X equals to a number. Okay, and these can be lower, so lower means left side, lower means down. This is the region. All right, the working is shown. The maximum number of seating capacity is 348 using the constraints and your answer from the previous part. Design a tiered seating for the theater. In your answer, you should identify 3 factors. Again, the factors are your conditions. Number of seats in one row, the total capacity of the hall, the dimensions of the hall, the gaps that must be left between the seatings and the ends, the width of the theater, the seats available, literally everything. Okay, easy. Calculations for the number of seats per row, calculations for the number of seats in the whole tiered seating. Okay, again, that's really simple. You know that the total width is 30, and you can have 5 seating sections in one row. Okay, so 1 2 3 4 5 6 6 gap 6 gap 6 gap 6 gap 6. You have 30 people in one row, and I can even place the seating sections over here to show that by showing the gaps also. Okay, so It's really simple. You've already done that. Okay, so it's 6 plus 6 plus 6 plus 6 plus 6. That's 30 people in one row. And maximum number of tiers that you saw in the previous calculations of the previous parts was 12. So why don't you just multiply 30 with 12 rows. Now you would see one mistake over here. You've crossed the maximum capacity of 348. So why don't you just have 11 rows? Don't have 12, have 11 rows, or maybe have 10 rows. Okay, so if you have 10 or 11 rows, you'll reach to 300 or 330, and then just add your sections of 6 seats or maybe 12 seats. Just work in the multiples of 6. You will eventually reach 348. It's as simple as it gets. Okay, so while making your designs, make sure to follow all the conditions. Leave a gap of 2 meters at the start and at the end. Leave a gap of 1.5 between every seating section, and don't have more than 5 seating sections. Don't have more than 12 rows. Impossible. Okay, so I have 5 seating sections. 1 2 3 4 5. 1 2 3 4 5. I have a 2 meter gap, more than 2 meter gap, because I can't have the 6th section. 1.5 1.5 1.5 1.5 gap left. All conditions followed. These are, I think, 11 rows. This is, I think, 11 rows with the 12 seat over here for this and this. I think it's going all the way till 348 or something. Okay, so just try to reach the seating in between 330 and 348. I would advise a maximum of 348, and you'll be good to go. It's as simple as it gets. Follow the rules. The calculations are literally addition, subtraction, multiplication, and you'll get there. Justify your design. This was just an example which was really simple. I made the best use of the canvas space, making sure that all conditions are followed, and I think I've made the best use. I was able to seat the maximum number of people. And this finishes May 2022. Alright, so the last question, November 24, designing a rooftop garden. It's based on volume and geometry and designing. So let's go. This is our question. In this question, we'll make calculations to help a community design a rooftop garden and to grow tomato plants, and they are grown in a pot. A pot is a truncated cone, meaning a cone that's cut. So if I interact with the stage control, this is what the pot is. So I need to cut the cone from over here. So the removed cone is this one. The total cone is this one. So if the question asks me to find the volume of the pot, that's really simple. The volume of the pot is simply going to be the total volume minus the removed cone volume. Okay, so the total volume of the cone, which is 1 over 3 pi r square h, where I know that the radius is 15 and the height is 240, minus 32720. So when I do all of that and I give my answer to the nearest 10 centimeter, it comes out to be this answer over here, which is 23830 to the nearest 10 centimeter, showing the non-rounded answer and then the rounded answer also. Okay, so moving on, I go to the next page. Part number 7b, pots will be filled up with soil up to 90% of the maximum capacity. Determine the volume in liters of the soil needed. So first of all, 90% of the pot capacity, 90% of this, I find that out first, right? This is centimeter cube. I need my answer in liters. So how to convert centimeter cube into liters? I'll use this. I can convert centimeter cube into milliliters directly. How to convert milliliters into liters? 1 liter is equal to 1000 milliliters. So divide your answer of milliliters by 1000, and you will have your final answer over here as shown here. Okay, so for centimeter cube, 2 milliliters, direct conversion, divided by 1000, 21.445 liters, or you can also write it as 21.4. That's also correct. Okay, so this is our answer. 7c, find the total cost to grow 1 tomato plant. The total cost to grow 1 tomato plant includes the cost of the pot, the soil, and the tomato plant. Okay, so the total cost is 3 things: the plant, the pot, and the soil. Plant is $6, easy. The pot, again, empty pot, 1.5, and then the soil is basically for 1 liter, it's this cost. So if 1 liter costs 0.4, how much does these many liters cost? Multiply. So when I multiply that and I get my answer, I can write it as 16.078, which to 1 decimal place or 3 significant figures, whatever, I think it's better to round it. That's 16.1. Okay, again, that's really simple. moving forward, again, there's a video. The community wants to grow their plant in a rooftop garden. They have the choice to follow a square arrangement or a triangular arrangement. Both diagrams are given. If these diagrams were not given to you, you should have used them from the video by pausing the video and drawing them on your notebook. Okay, so find the length L1 for the square arrangement. We know that the radius is 40. 40 plus 40 plus 40 plus 40. This is L1. 40 multiplied by 4, that's 160. L2, 40 plus height plus 40. This is an equilateral triangle. When I divide an equilateral triangle into two parts, let me zoom in over here. When I divide an equilateral triangle into two parts, three things happen. This gets divided into 30 and 30. I get a 90-degree over here, and the base gets divided into 40 and 40. All right. So I want to find h. This is a right angle triangle where this can be the hypotenuse, which is radius plus radius, 40 plus 40, which is 80. The base is 40. So why don't I apply Pythagoras to find h? I'm going to apply Pythagoras on the next page. I find h. So L2 is 40 plus h plus 40. Okay. So going to the next page to apply Pythagoras, that is there. Over here, h is 69.28. L2 is 40 plus 40 plus this, which is 149.28. Easy. Alright, design a rooftop garden. You are free to choose any configuration that you like. You are free to choose other things also, but make sure these are basically the draggable circular spaces that you're gonna use. Okay, 3 relevant factors for your design. The factors are really simple because everything that's gonna affect your design is gonna be a factor. And I've basically made the final design over here. I drew it myself in Microsoft Paint. That was really simple as well. So the dimensions of the factors are the dimensions of the garden, the length and the width, the dimensions or the radius of each pot or the space left for each pot, the arrangement selected to arrange the pots, the total cost involved, literally anything. Okay, the soil, the cost of the soil, the cost of the pot, everything is a factor. All right, show the calculations for your design. So literally, if I know that my total length is this and my diameter is 80, so why don't you divide this by 80? You can know how many pots you can place in a line. Why don't you divide this by 80 as well? You can know how many pots to place in a column. So when I do the calculation, I'll get an answer of 4 point something over here, which means 4 pots can easily be placed in a line. I'll get an answer of 3 point something over here, which means 3 pots can easily be placed in a line. Or you can simply do addition and get to that answer if you don't want to do division. Okay, so I've done multiplication again. That's really simple, and I've shown all of my calculations over here. The diameter of each pot is this, the length of the garden is this. So if I multiply 4 pots in a line, that's 320. I can't add more pots, to 4 pots in a horizontal line maximum, 3 pots in a vertical line maximum. Following the square arrangement, we can have 12 pots in the garden, easy as pie. Okay, moving forward, show the design on the canvas. I've already shown that. You can drag and drop. You can clearly see I cannot add anything else. Again, I will choose the simpler approach. The simpler approach is this. This seems a bit complicated. I'm not gonna go near it. Okay, I will choose simplicity. Find the cost to a sensible degree of accuracy of the complete scenario. So you know the cost of 1 pot, right? Why didn't you find the cost of 12 pots? Again, really simple. Multiply that by 12 and round your answer to 2 decimal places. You can say, and like, why do I choose 2 decimal places? What's my logic? I have convinced the examiner by saying that all of the other costs previously are given to me as 2 decimal places. So I should choose that. Simple. I could have selected 3 significant figures also, but I think 2 decimal places is much more logical. Okay, justify whether your results make sense. This is just a common way of saying justify the degree of accuracy. You can say that the results make sense, I've done everything right, and blah blah blah. You can say all of that, but I have chosen the contrary approach. Okay, the results do not make sense because it might not be possible for the entire community to use pots of the same dimensions. If you're actually using one rooftop garden for the entire community, that might not be insufficient. It is also unlikely for every garden to be of the same dimensions. The dimensions can change. The amount of soil, if you're not measuring it properly, that can differ. If the amount of soil differs, the cost differs. There can be inflationary measures on the cost can change. So if the cost changes, the whole feasibility changes. literally you have a lot of options over here. Okay, so that basically finishes this question, and that finishes all the questions of type 2 design questions.